Hello, everybody, and welcome to this week's discussion on low poly modeling. This week, we're going to talk about some techniques that you can use in Maya to decrease your polygon count on your models to make sure that they run more efficiently inside of a game engine or a rendered scene. And why that's important. I've got a couple of slides here to help with the conversation. We want to know why low poly matters. The most um, important thing to look at when you're actually putting 3D objects into a video game is efficiency on your system components. Every time that you ask a video game to render a frame, that takes a certain amount of time and a certain amount of computing power. And we want to make that as efficient as possible to increase frame rate as well as make the scene look the way that you want it to. We talk about polygons when it comes to 3D models. And as we've discussed in last week's modeling tutorials in Maya, polygons are the faces of a 3D model. They make up all of the rendered portions of a model. So when they are when there are millions of polygons in a scene at one time, it makes it a lot harder for your graphics card and CPU to process and render those images. Here we have a couple of very good examples of efficient 3D low poly modeling. The Mario the Mario wireframe is a little old at this point, but the idea, if you look at the breakdown of the tries, faces, and vertices of the model, um, Mario and Sonic Olympic Games from 2014, 2016 for the Wii U had a total of about 10,000 triangles, 10,000 faces. And then if you look at Master Chief actually in, I believe, Halo 4 had approximately 25,000 polygons in it. This is important to know because these characters tend to be on screen a lot, and they're also the hero characters. So we talk about in game development things like your props and your background objects versus your hero assets. Hero assets are things that are usually on screen a lot or are the most important parts of a scene. Your characters, your guns in a first-person shooter, cars in a racing game, things like that. And it's important to budget an amount of processing power for those, because so that they always look the way that you want them to on screen, no matter how powerful the system is that's running the game. So for something like Master Chief being 25,000 vertices or 25,000 tries, that means that while he could be millions of tries if you wanted to get incredibly realistic in the detail, it's important to reduce that because they're on screen constantly. Why does low poly count matter in video games? The most important thing is for efficiency, and what all kind of boils down to higher frame rates. At most, high-end game engines can render between 11 and 12 million triangles at one time. So any single frame on screen in a video game can max out between 11 and 12 million for the entire scene. That includes all of your background objects, all of your characters, hero assets, and also your scenery and landscape. The more triangles that are in a screen or in a scene at one time will reduce your frame rate and make it more difficult for lower end systems to be able to run efficiently. The target frame rate nowadays is about 60 is 60 FPS, and that translates to, believe it's 12 milliseconds of time between a single frame rendering. So the more things that you have on a screen, the longer that time to render that frame is, lowers your frame rate. And when we are rendering a scene with a single frame of a scene, that's called what's happening is it's draw calls. So draw calls are a request from the CPU to the GPU to render an object on screen. The more draw calls that happen, will slow down the amount or increase the amount of time for trying or for the frame to render. We use a general rule in game development that for most objects in a scene, we want to have one draw call. And for hero assets, we can go up to two. It's a pretty hard line to not go past two, because once you get to 3 and 4 and so on and so forth, it becomes exponentially more taxing on the system. So the question becomes, how do we efficiently model objects in 3D to adhere to these rules? And now we'll get into some of the tricks that you can do in Maya to lower your polygon count and create more game-ready models. Okay, so the first thing that I'm going to do, I'm going to work with our coffee cup that we made last week and show you kind of how we can reduce the number of polygons in this cup and make it more efficient for use in a video game. So let's start by showing. Oh, let me turn off my symmetry. There we go. Let's start off by showing what we're working with. And so if you go up to your display option here, go to heads up display, and then click on poly count. You'll get this box at the top with a bunch of different numbers. This will show you the number of vertices, edges, faces, tries, and UVs for your objects. The total in your scene is the left column, and the center column is the total in your selected object. So right now, if we look at that second column, you can see that the coffee cup that I made last week has 8,192 tries. That is a lot of tries. Remember when we were talking earlier that Mario from the Wii U Sonic and Mario and Sonic games has around 10,000 tries total in his character. This is a coffee cup. This is not Mario. So we definitely don't want to have that many in this, especially if we're building a scene that is in a cafe or cafeteria or something where there are a lot of people drinking coffee. So if we take a look at, I've duplicated this object and lowered the polygon count using the techniques I'm going to show you, just to give you a bit of an example of a before and after. So this coffee cup here, instead of having 8,000 tries, has 3,800 tries, 3,872 to be precise. That's actually still a lot, but a lot of it comes from the bottom here, which I did not do much to optimize, and the handle. And also, because of the way that we've set up the lip of the cup, the edge loops around the cup can also create a lot of faces. But that's okay. Again, we're gonna work with this model here, and we're going to show you a couple of things that you can do to reduce our polygon count. So the first thing that we can do is actually delete edges from the cup to create larger quads. So if you look at this cup here versus this cup here, there's much larger quads in the center section because we've deleted a bunch of these horizontal facing edges. And additionally, if we go into the cup, you can see that there's basically, based on compared to this one, very few quads left in the interior of the cup. That's partially because we don't care how the inside of the cup looks because it's not focal point of the object, and it's also because it doesn't affect the structure of the cup if we were to remove those edges. One of the things that we have to make sure that we do when we remove edges from a model is that we don't affect the shape of the object, because then we'll have a lower quality render, and it won't be as good of a model. It's kind of it's kind of the difference between a hyper realistic object and something that's voxel like, not necessarily voxel. It's a different modeling method, but it's kind of like a difference between that and a stylized look, something closer to like your World of Warcraft, where high fidelity models don't actually matter as much as a specific art style. But we want to keep this cup as realistic as possible. So first thing I'm going to do is I'm going to right click and then choose our edge tool. And then if you double click on an edge, it will grab the entire edge loop that it connects to. So you can see here we've collected this entire loop. So I'm going to show you a bit what I mean by removing structure and distorting the shape of an object. So if I were to hold shift and then double click a couple more of these edges, and then if I wanted to delete these edges, if you hold shift, right click, then you can go to delete edge. Now, you could, if you wanted to, just hit delete. If you do that, you may see that the vertices are still there. That's important because the vertices will affect the shape of the cup. So we don't want to do that. So I will bring these guys back up, go back into edge mode, and then what we'll do is we'll hit shift, right click, delete edge. Now that actually removes the vertices. If you take the vertex view, that actually completely removes the vertices as well, which is important, as I said before. But you can see that now we've distorted the shape of the cup. And now maybe that's a look that we want. We can worry about that when we model. However, as it appears, we've completely changed the shape of our coffee cup. So if we go back into edge mode, general rule of thumb is for round objects like coffee cups and things like that, is anything that is running vertically running down the length of that cylinder, you don't want to get rid of those edges. Those edges are more structural than the horizontal edges. So if I were to double click on these edge loops here, and while holding shift, click on a bunch of them, and then hold shift, right click, delete edge. I deleted all of those edge loops, which is about the same number of edge loops as I deleted before, and it doesn't affect the shape of the cup at all. It's because structurally the other horizontal edges here are keeping the roundness of the cup together. Now I could, if I wanted to, go even further and delete more edges. If I were to delete, say, this one, let's take a look at this one. Because this one intersects with the handle, and there's some complicated geometry going on where the handle extrudes out, we don't want to delete this one because it may affect the shape of that handle and create what's called n-gons. I'll be discussing that in a little bit when we go to cleanup, but N-gons are not things that we want to see in video games, and they actually really adversely affect the rendering speed of an object. So, if I were to delete this one, we may not see a problem in the shape of the cup, but we do see a problem if I go into face mode, for instance, so I can highlight it better. We do see a problem here where we've created n-gons. N-gons being polygons in a 3D model that have more than 4 sides. So quads are fine, triangles are fine, n-gons not fine. So let's go back and delete or return that. Go back to our edge tool, and we're going to avoid these edges here that connect to the handle because it's going to create n-gons. But what if we were to delete this edge and this edge? Another rule of thumb is to not delete things that structurally create curvature, like the lip of this cup. If we were to delete this face here, then the actual connection between, or this edge here, if we this edge that we've highlighted up to this edge, then becomes more straight and angular, and it'll sharpen the edge of our cup, which we don't want to do. But these two should be fine because they don't connect to any other edges in ways that will create n-gons, and also they aren't structurally important to the cup. So let's delete those. And now we'll go down here, and same deal. Holding shift, I'll double click on these edges here, get the whole edge loop, shift right click, delete the edge. All right, there we go. So now let's look at the inside of the cup. As I showed with my finished version earlier, basically I'm removing every interior edge loop in this cup. It doesn't matter what they seem like they are important for. They don't actually affect the shape of the interior of the cup. That is being controlled by the exterior of the cup and the edge loops that attach to the edge and bottom of the cup. So if we zoom in a little bit, again, I don't want to delete the edge that connects to the curvature at the bottom of the cup, because it will cause issues with the shape of that bottom of the cup. So let's not get rid of that one. And similar up here, we want to keep the lip the same shape, but we can probably delete all this stuff and not affect the shape of the cup at all. Oh, looks like I accidentally deleted a vertical face or vertical edge. We don't want to do that. Oh, I see what happened here. I accidentally deleted an edge here. Let me fix that real fast, and I will come back. All right, we're back, and I have fixed our issue with the cup. Required me to go back a bunch and then reselect the edges. Sometimes, depending on the tool that you're using, if you click on certain things, edges or faces in a 3D object like this with symmetrical things inside of the geometry, you may get things that connect, in places you don't want, like say like that. I use a lot of undoing to fix those issues, unless it's too far gone, and then you can do adding edges and things with multicut. Where if I had done that and I wanted to fix it, I could use our multicut tool and choose 2 points to create an edge, and then right click to make that a full edge. I'm not going to do that right now. We don't need it, but that is how you can fix that when you see geometry that doesn't look like it should. All right, so we'll go back to our edge mode, press Q to get rid of that multi-cut tool. The next thing that we're going to do is look at the bottom of the cup, because the bottom of the cup has a lot of this interior geometry, which these interior polygons, which I'm not going to be able to do much with in this lesson, but we can get rid of these edge loops around the bottom of the cup. So as you can probably see, the bottom of this cup is basically completely flat along that ring, which means that everything that is not a outside edge of that object or of that shape isn't necessary for the structure of the cup. So if we were to just remove all these, might keep that one because of the curvature there at the edge of the cup. And we'll see what this one does. I think that I deleted this one in the other version of this. So we'll delete that. Okay, I may not have. That looks like that actually did. Oh, no, I did. Yep, they look exactly the same. You may see when you do things like that, that may look like they should be fine, and then decide that you don't want to do that. So if we, you know what, let's just undo till we unhighlight that one, and we'll keep that one just to make sure that it keeps that structure around the dip inside the cup. Now, the next thing that we're going to do is go inside of the cup, and this is going to be a little bit more complex. Actually. Okay, so the next thing that we're going to do is basically do the same thing. I just noticed that I caused an issue. Let's get rid of that and delete that edge. There we go. Now we have a complete edge loop there. I'm going to do a similar thing to the inside of this cup. As you can kind of see, it's similar patterns of geometry with these interior quads kind of bulging out and then the rings around the edge. And just like the outside of the cup, the inside of the cup doesn't need these rings to be structural, so we can delete them. Now, what we want to make sure on this part, because it's a little bit more complex, is that we do not cause any n-gons to form while we're doing this. So once you get to like this point in here, you can see where this is creating a quad, and we don't want to delete any of these edges and cause this quad to extrude out into a n-gon or something with more than 4 sides. So let's leave it there and then delete these edges. And then if we want to just double check, if we go to face mode and we just highlight over these different faces to make sure that none of these look larger than they should be, more n-gons being formed, everything looks good. Everything in the interior looks good. All right. Whoops. And we'll go back to edge mode. And just to double check my math over here, because I think I actually deleted a bit more on this side. Whoops. Oh gosh. There we go. Yeah, I totally did. All right, so now that we have these deleted, let's go further in and see if we can do some more. So make sure we're on edge mode, and let's start here, and here, and here, and here. And we're going to go one at a time here because we want to make sure that the geometry doesn't deform in ways that will create those n-gons. Maybe we can go one further. Let's see. No, we cannot. And you can tell because this edge loop has now extruded out to the entire cup, to that vertical edge loop around the outside of the cup. So that's structural, and we don't want to mess with that. So now if we look at our cup here and how it looks, oops, let's not let's not look through it on the other cup. How this cup looks here versus this cup here. I was able, it appears, to remove a couple more edges in places. Not entirely sure where I was able to do that, but we have reduced the size of the cup from its original 8,000 tries down to about 4,000. And you can reduce it even further the more that you want, the more that you go into deleting these edges. But again, this is a very manual process and can be very time consuming, especially if you're in a very complex object. I will try to show you. Do I have it saved? Yes. Yeah, we can save this. All right. So let's look at something that's way more complicated and what we wouldn't want to do with manual edge removal. So this object here, this is a 1901 race car that we're using in a video game that Dogwood is making. And this object, which I will click on to show you the wireframe for, hit 4 to open up your wireframe. And if you look at our poly count over here, our tries, we have about 5 million tries throughout the entire model, 4.5 million for the car that I clicked on, and then this gear box situation over here has another 500,000 tries. This is an incredibly dense, incredibly heavy model, and definitely not something that we want to use in a video game before it's reduced. But this is a good example of, if I hit 5 to pull up object mode again, and it'll go to edge mode, a good example of let's not let's not use edge loops to change geometries, because if I were to say want to remove that or this edge loop, let's say, there's so many intersecting edges all over the place that you can run into issues with n-gons and things being created haphazardly, and you can completely ruin geometry. Something like this is used for something with this many polygons is used for architectural visualization, cinematics, specifically movie cinematics and things, where you can have a powerful machine pre-render everything in a scene and stages, and then it gets put together in like in a movie. So we don't want to, we're not going to worry about this thing. But this is a very large model. And I like to show it off as a example of not inefficient poly reduction. What I will do though is we'll go back into our base coffee mug. Okay, we're back in our coffee mug project. We have our 2 coffee mugs here that I have reduced the poly for, and I want to see what happens with another tool that is going to do what we just did automatically. First, I'm going to import my coffee mug, my original coffee mug that is right here. And we're going to drag that over here so we can see it. So I want to reduce this, but maybe the geometry is simple enough like this is, or maybe the let me hide that. Maybe the design of the object is symmetrical, so it's a lot easier to do it autonomously, but maybe if there's a lot of triangles or a lot of edges that I don't want to manually remove because it takes time, Maya has a lot of very powerful tools to help with the automation. So we're going to start by going to mesh, and we're going to go to reduce. We're going to click on this dialog box to open this up. So reduce will, depending on the settings that you've made, automatically reduce polygons to try to create the same general shape without losing any of the structural integrity of the object. So when you open it up for the first time, it'll have its percentage set to 50. This is going to reduce the number of polygons by 50%. You can also change based off of your vertex or triangle limit. This can set the number of vertices or triangles you want on your mesh, and it'll reduce to that number or as close to that number as it can get. We don't want to touch anything else here. Preserving quads will preserve the number of quads in the topology to not the number of quads, the percentage of quads in the topology, so that it stays the same shape. If you keep it at 1, it won't worry about cutting any quads into triangles or anything. Totally fine. We hit the reduce button. And this is what we've come up with. This is what Maya has determined. Okay, so while I was editing this, I actually realized that the last part of this video got corrupted. So I'm going to record it again. Unfortunately, I noticed, or I did not save my last version of this file, so I've lost my third cup. Let that be a lesson to everybody. Make sure that you save often. You don't want to lose your spot, your progress, especially when you've done a lot of work to an object. So the last thing that I wanted to show was a very useful tool towards the end of your workflow that'll allow you to clean up any issues that you have for parts of your mesh that are not optimized and can really bog down, whether it's the number of polygons in the mesh or the rendering of that mesh in a scene. So we're going to go into mesh and we're going to go to the cleanup tool. Hit the box here to pull up the dialog box. And there's a couple of things going on here. First off, we have our operation. If cleanup is marked, if we hit the cleanup button, whichever options we've chosen below here, Maya will perform. If, however, we click on the select matching polygons option, what that'll do is any of these options, it will select them on our mesh and show them to us, so then we can then go in and fix them ourselves. Our options, that ones that we'll mostly be focusing on for this that you may run into, are your faces with more than 4 sides, which are your n-gons, which we were talking about before. Things, lamina faces, which are faces that share the same edge. So basically they are exactly on top of each other. And for whatever reason in the construction of the model, Maya has identified that there are actually 2 polygons, and these polygons are sharing the exact same edge. And then another one that we want to deal with is edges with 0 length, which means, similar to lamina faces, there are 2 points, and those points are exactly on top of each other, and they have been attached as what Maya recognizes as an edge. And we don't want to have that. These are all different duplications of things that we don't that will bog down our mesh in the end. So let's get rid of those. We're going to start by actually going to create a n-gon so I can show this to you better. So we go into our mesh. I said that this edge loop here earlier, if we were to delete this, would create an n-gon. And in fact, I believe it creates 2 because it's symmetrical. One here and one here. These guys have 5 sides. It's not what we want to see. So if we go into our cleanup options and we choose faces with more than 4 sides, and we clean up, it'll highlight those for us and show us that we have 2 n-gons on our mesh, and I believe those are the only 2. Yeah. So now we can go back into this menu, and we can set up let it clean it up. So if we hit the cleanup button and then hit the cleanup option and hit cleanup, now it's taken those n-gons and it's split them into 3 triangles. That's much better. That is optimized. It's the way that we want to see it. So we can keep it like that. As a side effect of this, by doing this, we actually reduced the number of tries in our mesh, because we deleting that edge loop, we actually created half the faces around the edge of this cup here. So we can leave that the way it is, and the cleanup tool actually helped us optimize a little bit more. I don't believe there's anything else we're going to have problems with on this mesh, but I will go through the cleanup options and show you. I'm going to uncheck faces with more than 4 sides. I'm going to select matching polygons so that we can see if there are any issues. And I'm going to check off lamina faces and edges with 0 length. And then we're going to hit cleanup. And you see that the mesh... the wireframe left the cup, which means that there is nothing to select on the cup. So we are good to go with all of our errant geometry. Usually after you do a cleanup and you're happy with everything, you will then move on to exporting your model, rendering it in a scene, so on and so forth. So that was the end of that. That's the part that got deleted by accident. So I am going to go and edit the rest of this, add it to the end. Thanks, everybody, for checking out this week's discussion, and make sure to work on your low polygon projects for the end of the week.